This is distance from a point to a line. The distance from x1, y1 to the line ax plus by plus c equal to 0 is given by d equals the absolute value of a times x1 plus b times y1 plus c. All of that is divided by the square root of a squared plus b squared. Now, what we're talking about is the point is not on the line. The equation of the line is in general form, and you're drawing the shortest distance from the point to the line, and the point could be anywhere on the line, but you're talking about the shortest distance, so that's the perpendicular distance. I've drawn a picture here with the line with the point above the line, and then another one with the point below the line. And again, this is the perpendicular distance from the point to the line. Find the distance from the given point 4, -1 to the given line 2x plus y equals 5. This point is x1, y1. The line we first have to put in general form, so we need to rewrite it as 2x plus y minus 5 equals 0. Then we know that a equals 2, b equals 1, and c equals -5. Then using that d equals the absolute value of a times x1 plus b times y1 plus c, all of that's at absolute values, over the square root of a squared plus b squared, and we get 2 times 4 plus 1 times -1 minus 5 over the square root of 2 squared plus 1 squared. Simplifying, we get the absolute value of -5 over the square root of 155, which simplifies to 5 over 3 square roots of 17. It is perfectly good to leave the square root in the denominator. Find the distance between the given parallel lines. 4x minus y plus 2 equals 0, and 12x minus 3y plus 1 equals 0. The first thing we need to do is pick a point on one of the lines. I'm going to pick the line 4x minus y plus 2 equal to 0, that x equals 0, then we know that y equals 2. I could just have easily picked x equals 1 and find that y value, but I'm using x equals 0 just to make things simple. Now, I'm going to use the point 0, 2 and the line 12x minus 3y plus 1 equals to 0 to find the distance between the point and the line. Because this point lies on one parallel line and the other line is the other parallel line, this will tell me the distance between the two parallel lines. So d equals the absolute value of a times x1 plus b times y1 plus c, all over the square root of a squared plus b squared, which equals 12 times 0 minus 3 times 2 plus 1 over the square root of 12 squared minus 3 squared, which simplifies down to 6 over the square root of 5. Find the lengths of the altitudes of the triangles with sides x plus y minus 3 equals 0, x minus 2y plus 4 equals 0, and 2x plus 3y equals 5. Recall, the altitude is the perpendicular distance from the vertex to the side opposite. This is the same thing as finding the distance from a point to a line. So the first thing we need to do is to graph the lines. So I'm going to label the lines A, B, and C. Then when I graph them, I have line A, B, and C. Next, I'm going to use my lines A, B, and C with my graph. Now I need to find the intersection of the sides of the triangle so that I have the vertices of the triangles. So I'm going to find the vertices Z, which is the intersection of A and C, line A and line C. To find this, I have already solved each A, B, and C for Y. So all I'm going to have to do is set A equal to C. So that's minus X plus 3 equals minus 2/3 X plus 5/3. Multiply both sides by 3, so I get minus 3x plus 9 equals minus 2/3 X plus 5. Then I find that X equals 4. Y equals minus 4 plus 3, which equals negative 1. So Z is the point 4, negative 1. Now I need to find the point Y, which is the intersection of line A and line B. Again, I'm going to set A equal to B, so that's minus X plus 3 equals 1/2 X plus 2. Multiply both sides by 2, so I have minus 2X plus 6 equals X plus 4. So X equals 2/3. Find Y. Y equals minus 2/3 plus 3. So Y equals 7/3. So Y, capital Y, is the point 2/3, 7/3. Now we need to find the vertex capital X. This is the intersection of line C and line B. So we're going to set negative 2/3 X plus 5/3 equal to 1/2 X plus 2. Multiply both sides by 6 and we get negative 4X plus 10 equals 3X plus 12. So we find X equals negative 2/7. Then to find Y, we have 1/2 times negative 2/7 plus 14/7 gives us 13/7. So X is the point negative 2/7, comma 13/7. Now the last step is to find the distance from the vertex to the opposite sides. This is the altitude. So from Z to line B, we find the distance, so that's going to be 1 times 4 plus negative 2 times negative 1 plus 4 divided by the square root of 1 squared plus negative 2 quantity squared, which gives us the absolute value of 4 plus 2 plus 4 over the square root of 1 plus 4, which is 10 over the square root of 5. Notice that cannot be simplified, right? To find the distance from Y, which is 2/3, 7/3, to line C, which is 2X plus 3Y minus 5, is 2 times 2/3 plus 3 times 7/3 minus 5 over the square root of 2 squared plus 3 squared, which gives us the absolute value of 4/3 plus 21/3 minus 15/3 over 4 over the square root of 4 plus 9, which goes to 10 over 3 square roots of 13. Again, that is as simplified as it can go. The altitude from X to A, X is negative 2/7, comma 13/7. A is X plus Y minus 3. So we have the absolute value of 1 times negative 2/7 plus 1 times 13/7 minus 3 over the square root of 1 squared plus 1 squared. So we have minus 2/7 plus 13/7 minus 21/7, the absolute value of that answer, over the square root of 1 squared plus 1 squared. So we simplify down to 10/7 square roots of 2. Again, that cannot be simplified. For the last question, find an equation for the set of all points whose distance from its origin is twice its distance from x plus y minus 1. There are two ways to read this question. One is where the its refers to the distance from the line to the origin. And so what we're talking about is you want a circle where d, where the radius is twice the distance from 0, 0 to that line. So that's one answer. The other one is where you have the distance from the origin and all the points x, y is 2 times the distance from the line x plus y minus 1 equals 0 and all the points x, y. Both of these answers are worked out in the notes. Okay? The top way is really easy. So you calculate the distance from the origin to the line, and your radius is that distance, is twice that distance, and you got a circle. The second one is you have the distance, so the distance formula equals twice the distance xy from the point. So you have 1 times x plus, where 1 is the coefficient of your line, A, times x is your point xy, plus 1, which is the B, times y, minus c over the square root of 2, and you want twice that distance. So that's a harder question. That's more, actually, it's gross algebra. So both answers, but when you work them both out, they're both circles. The whole point of this question is the whole entire next lesson, the whole entire next week is nothing but circles. And so the reason we're doing this last question is to lead you into circles. Let me know if you have any questions. Thanks.